There we go.
Okay, what I've got here is I got 10 dice here. And if you look at it, I got 6 choices, 1, 2, 3, 4, 5, or 6, very discrete. So what I'm going to do is I'm going to take these 10 dice, just roll them, and then I'm going to plot out, record what I get out of those 10. And that's what I've got here on this chart. And I'm going to do this 20 times, write down the individual scores, and then I'm going to take the average of the 10. Now what that should do for me is I would expect the distribution, if I were to plot this out, just keep on making X's wherever they hit, eventually I get a nice uniform distribution, very discrete. The trouble with this is we can't analyze it statistically using a normal curve. And that's what I got actually when I actually did the histogram on this. It's kind of interesting. You see what's called clumping here, right? And that's going to happen. That's going to happen, and it's not unusual just by random chance. Okay, but what I want to do is get this into a normal curve somehow. So what I did, I go back to my data again. I got this average, and instead of plotting the individual x's, I'm going to plot the individual averages, or the averages of each of those 10 groups. Well, if you think about it, the average roll of the dice is going to be equal to about 3.5. So this thing's probably going to be, I'm hoping that this will be centered about 3.5. And as I plot the individual x bars, and eventually I'll make a normal curve. And then I can work with that. And if you look at this, this is what I did on this. I plotted the averages. And again, you can see here's my 3.5, and it's starting to make that normal curve. Again, I've only had 20 shots at this thing, and it is spread out quite a bit. There's going to be a lot of variability. But if I do this long term, eventually I'd end up with a normal curve. And this is what's called the central limit theorem. I can take any type of distribution and turn it into a normal curve, or I can do probability and analysis with it.